Hello and welcome back to our webinar series. I hope you all had a relaxing holiday season. It was a very long time since our last webinar. And well, I hope you are fully energized back to the battery business. Today, I'm supported by Marco.
Hello, my name is Marco. I'm product manager at BM Rosenthal related to assembly and manufacturing solution for lithium-ion modules and packs.
My name is Stefan Handel. I'm your first contact for all your requests related lithium-ion, sodium-ion, and other new energy types of battery projects. You will find my contact details then at the end of this session at the final slide. Please feel free to contact me for all your requests that you have in addition to this webinar. For those of you who are new to this webinar, we will have now a 15 minutes technical presentation and then 15 minutes time for questions and answers. We had already 3 webinars before today. In the webinar number 1, we started with single cells, how to prepare them for the assembly steps, testing, foil application, stacking.
And in the webinar 2, we had a deep dive how to build from a cell stack a rigid module using state-of-the-art technology by laser welding, hotspot welding, how to bring metal parts or even metal straps into the stack and form the module.
And in the last webinar before the summer break, we were talking about the decisive step of busbar welding, mainly with laser welding. And today we're going to finalize our product. So how to make now a final rack back battery system using maybe also some manual steps. Before we were talking mainly about automatic processes, and at the end of a production process, how to test your product before it's going to be delivered out to the market. Of course, everybody is talking about automatic assembly, but in battery business, due to different reasons, also manual steps cannot be avoided or have in certain circumstances also a reason for certain advantages. A very typical reason to stay with a manual process is as you don't have yet the quantities, and very often it also happens in our projects that the standardization of your final product is not as mature and does not allow yet a full automatic system or makes it too complicated to adapt later on. And one more reason is also in the supply chain. So very often with these new kind of products that come to your production, the supply chain is not yet established. Simply, you don't know how it is packed and how it's coming to your production. So a simple example is at the very beginning of such a module and pack assembly, you start with a single cell. And when you have the flexibility with different cell suppliers, there is not yet a fully established standard of the packaging. So very often we start now with manual cell loading to an automatic line. It would be very easy in this case to bring in an automatic solution by a robot or gantry system for this kind of process. Now we will have one question for you. So what do you prefer in your production, or what is your need? Do you need more manual processes, or you are already looking for automatic processes? So I see tendency is rather going to automatic, or even the most of the answers we have on the no choice or not yet decided. And depends on the situation, as I explained to you. Other typical processes that rather stay manual are, for example, the application of a module to the rack, the cell loading. You see already here a video of manual assembly processes, how to do wire harnessing in an automatic process, how to bring the electronics to the final product, how to place the bus bars, for example, cooling elements, fans, and cooling circuits, and also finalizing your product with label printing. I will show you again this video. You see here one of our production lines where at the end for the final pack assembly you have certain processes done in a manual way. Here you see now a front view of 2 of such stations. So the stations are connected to each other directly in the production cycle. We have several guiding systems to support the operator to do their jobs correctly and also in a safe way. So you see here the mechanic guiding system for a screwing head, professional screwing heads, which can allow the control of torque and rotation angle, for example. You see here also some protective acrylic glass, which is on the one hand necessary for the safety of the operator, because you're already working on real loaded battery cells and modules, and you can at the same time use such protective layer for the guidance and for the position control of the screwing head. A critical task, how to bring the raw materials into the working area of the operator, and how to do the guidance of the operator. So our HMIs can work as a guiding control and guiding support for the operator. Here, a main screen of such a manual station where step by step the operator can choose the jobs that he has to do. And here, one detailed job, in this case, the example, how to fix the front cover handles on a final battery rack. And here, the operator, together with the process equipment, has to confirm that the processes are done correctly. Here are some more pictures. So at the first picture to the left, you see such a guided screwing head working through the protective layer to fix the module into position. On the middle picture, you see an angle screw head to fix the top cover of the battery pack. And also at a certain point, you will have to work on the modules and battery cells directly. So it's necessary to have insulated tools and protective equipment for the operator to make the final connection of the battery system. Here you see also on the left side a detailed picture of this a screwing head with the insulation elements on top and below until the real final screwing head, which is made of insulating material. So you see, many people think that doing jobs in a manual way is a more simple task than automatic station. Up to a certain extent, this can be true, but I hope I could get you the short insight that at the end, that can be a very complex job. We have the know-how, we can support you, so please address us also with your manual jobs that you want to do in battery assembly. So now the battery is finished and ready for delivery, isn't it, Marco?
Not so far. Prior we can go into delivery, we need to conduct an end-of-line testing procedure. End-of-line testing is a crucial step to guarantee the production functionality and as well the safety of the product, that there are no errors, no failures on it, that there could be a safe product delivered to the customers. Depending on the requirements and as well the application, a various amount of different kind of test procedures can be conducted. Prior we go into the deep dive, we will give you our questionnaire too, where we have listed different kind of test procedures to give you a possibility to answer and to see what are your demands. Are you having all of those in place already, and what are your future needs of this?
So in this case, we have multiple answers possible.
Correct. We will wait a few seconds more that we have the feedback effort and evaluate it. Okay, so we do see that the most of you conducting electrical tests, followed by the verification of the BMS and as well the visual inspection. Okay, let's have more insight and deep dive of our proposed solution. The various variants we have seen are going from the tightness test, which ensure a high reliability on the leakage, that there is no defect in the product coming to the tightness of a housing, or even if there's a cooling installed in the product, that the cooling compartment has as well no leakage, which could have a failure cause related at the end to maybe an thermal event. Another point which was mentioned as well in the answers is the verification of the battery management system. This means functionality, software release, and communication. Another possibility are the electrical checks, which include more different kind of electrical checks. We would go furthermore in the detail, and as well what is important at the end, the adjustment of the delivery charge of the battery to fulfill all legal requirements and as well according to the specification. And one of the last points to do is making a visual inspection to verify characteristics of the product and store everything together in our management, the battery management control system for the documentation and the traceability. Going a little bit more in detail of the tightness test, you can see here a differential pressure drop measurement device where we are going to connect the battery on a plug, make a test setup with a defined pressure. This could be overpressure or as well under pressure, depending on the requirements. And this can go from -50 millibar up to 2000 millibar, for example. If there are high requirements on the low leakage rate, we can conduct as well another test scenarios using helium sniffing method or even a helium chamber, which is more related to tightness of battery packs in with cooling systems. When it comes to the electrical check, it's very important to have a proper connecting system which connects the end-of-line test with the battery pack. You could see on that slide our connecting mechanism, which is done fully automatic, having a tolerance compensation system implemented to have a low force connecting to the electrical probes of the product and to avoid any kind of pre-damage. This is quite important to ensure high quality products at the end, which are delivered to the customers. Besides the automatic way of contacting the battery pack, it is well usable to have a manual connection, which is protected with a protection door to fulfill all legal requirements for high voltage test places. The electrical checks which we conduct, we mentioned the verification of the BMS. So we would establish the communication check and the wake up of the battery management system. We could do the verification of the software release version of the BMS. And if it's needed, we can conduct direct inline at the end of line, the flashing of the software to the latest released version. Beside that, we would do the initial diagnostic of the battery and evaluate any kind of failures or going into a resetting of the failure for the first ignition, which can occur during different kind of assembly steps. However, after everything has been established in communication and the diagnosis of the BMS, we can start with the test procedure, which usually starts with a voltage measurement of the battery system and doing parallel the verification of the thresholds, which are stored in the recipe, and even the counter check if the BMS would measure the same value and the defined range. Beside that, the next step would be to do a high voltage test. This is mostly related to the high voltage insulation test, where we set up a voltage of up to 2000 volt DC onto the housing and the battery plus or minus pole and measure the insulation resistance, which to be up to a certain level to have the guarantee that there is no insulation failure, which could cause any kind of impact on the battery pack level. Next test scenario would be to conduct high power discharge and charging pulses to see the behave in functionality of the battery. These values we would measure in a high accurate level to evaluate the respective DCIR, which is the inner resistance of the battery, to see if there is the high voltage part of the battery working in a correct manner, and that's in the relation of the inner resistance of the cells, that the system works properly to fulfill the lifetime requirements of the product. Beside that, with those values, we can evaluate as well the battery capacity, which is quite important for the functionality and as well of the lifetime of the battery. In kind of deviation to the required state of charge for the delivery, we can charge or discharge as well to the certain level which is required of the battery. Coming to the visual inspection, we can conduct a fully automatic visual inspection, or it can be done by the operator. Those test cases could be that every kind of transportation cap, which protects the high voltage plugs, the communication board, or even the cooling compartment, there cannot be any kind of dust going inside during the transportation. We can recognize with smart cameras and the related functions, and we can store every picture to have the full traceability of the final product, which is quite important to ensure high safe product production.
So, thank you for this presentation, Marco. Now we have a final product to be sold. Maybe the final labeling and packaging, it can be again a manual process or automatic. We would like to discuss your demands for all your production steps of module and pack assembly together with you. Please feel free to contact me. The next chance to meet us personally, if you're also there, we will be as visitors at the battery show in Detroit, coming up now in October 7th to 9th. And we will exhibit also at the batteries event in Lyon at the beginning of November, from 5th to 7th of November. I hope to meet one or the other there. And now it's time for your questions, and we will try to give you the answers. How do you control the manual processes? Is there a data storage? Question
yes,
for you.
We can answer it. Yes, we have installed a data storage system which tracks and monitors and controls every kind of process step which is conducted. So based on the recipe, we have defined thresholds, defined working procedures. We can implement as well optical systems for verification of process steps which are conducted. And based on that algorithm we have developed, we can store all that data related to a serial number of a product. And at the end of the line, we can generate the part history document, which is stored on the system and which can be exported to any ERP system or even sent to a printer and can be directly be connected to the product.
But of course, I think we can summarize that due to all the working behavior of humans, it's a little bit more complex to control the quality in the manual processes. So in the meantime, we are waiting for more questions. What I would like to add to the complexity of manual processes, what I might not have answered, is how to integrate them into a fully working automatic loop. So of course, in the automatic processes, we do a cycle time analysis and we adapt each station to the complete cycle time, but you have to do then the same if it's done inline. You have to do the same with manual working steps, and that's it's, let's say, also a difficult and tricky task to define the single working steps and to bring the cycle time into the material flow of the production line.
So meantime, we got another question. It's related to end-of-line testing. Which current level is used for the electrical charge and discharge test? So coming up to that electrical test, there are different requirements, but basically it turns everything about the capacity of the pack or the model, which has been tested. That could be from a range of few amperes to 280, 600 amperes. So we are developing systems which can cover 1 C rate to 3 C rate in the normal behavior, or which are going up to 15 C if it's coming to automotive application or grid stabilization application to guarantee the performance which is required. So in total, it's coming from 2 kilowatt up to 150 to 200 kilowatt power end-of-line tests which we are producing.
So now we have a question for the organization. Are the previous webinars are still visible somewhere? Yes, of course. So for this webinar, as an attendee, you will automatically get a summary, a recording of this webinar. And of course, it's also possible to make the previous webinars accessible to you. For this, please feel free to contact me and I will send you back an email with the links to the recordings. One more question. Can you support in defining common EOL tests for prototype and series production?
So yes, we can of course support in the evaluation of test procedures, what you would need for your product related to the kind of application and your product design, to the aspects of design for manufacturing and prototype and series application. So please feel free to contact Stefan to go further in a discussion of your needs.
2 questions more. How long does the comprehensive testing take at the end of the line, including SOC adjustment, capacity, and other electrical checks? Do you need 1 full charge-discharge cycle to get the capacity, or partial charge-discharge is enough to test it based on SOC, gain or loss? First question.
So coming back to the first part of the first question, meaning the time duration of taking the end-of-line test, I would say answer beside SOC adjustment. So doing a capacity test, electrical checks, communication as well, it can go up to the 80 to 90 seconds. Depends on the power, what is needed and what is the allowance of the capacity, maximum capacity rate. Going to the SOC level, it could go up to 20 minutes to achieve the related delivery charge level up to the maximum performance. So we're considering a charge with 1 C or discharge with 1 C to go to the related level, and coming up from 20-25% charge level, maybe to 50% charge level, we would need approximately announced time of 20 minutes for that process. And based on the overall output of the assembly line, we work on a concept which may integrate this SOC adjustment in the line, or we would do it in an offline or separate station to achieve a minimum of investment of CapEx into the assembly process.
So in total, I think we can say end of line is a typical station that could require either multiple stations if you want to keep it in line, and then it's really contributing to a significant CapEx investment. or you try to do the time-consuming job, charge and discharge, for example, in an offline station, in a separate station out of the line. Yeah?
Correct. Coming to the second part of the first question, if we would need a full charge and discharge cycle to evaluate the capacity, basically we do not need the full cycle to evaluate the capacity. We are working based on, with our customers on peak power tests, so that we have small high power pulses of load and unload of the battery pack, and then we make the calculation based on the voltage drop off to the related capacity. To be, of course, 100% sure, you will make a full capacity load and unload test, which means charging to 100%, discharging again to mostly 0%, and then you do column counting for the capacity check. Beside that, of the end of line, we implemented as well test cycles in the production line that once per shift, a full capacity test will be conducted to have a continuous quality or additional continuous quality control of the cells which are used on the products. So for the second question is related to active or passive balancing in the BMS. We can go in an offline session more in that detail. So for the end of line, it is not as crucial if it's active or passive balancing. This is more related to the lifetime behavior and the application of the battery pack itself.
So going already into the battery design and battery know-how of the battery function, I would say. And similar question then, do you support also the engineering design of the modules, including
thermal
management systems? I would say that this is really when it's fully part of the product design. This is already out of our scope. What we can offer, we have a lot of good contacts with experienced engineers and the companies who can support you in the product design. Where we can start supporting you is in the question design for manufacturing. So which systems to choose and how to implement them mechanically and electrically so that it's a working and a simple way how to manufacture them and how to assemble the battery system.
Good. Are there any other questions? Otherwise, we exceed the supposed time what we had for this meeting and webinar. Anyhow, you have our contact information and we're available for you to support in any other question in matter of manufacturing solution we can offer.
So you will find now here on the final slide my contact details. Please feel free to contact me and or Marco. You will find us on our website as well, and hope to see you soon online or live during some personal visits and or at any of the upcoming battery related events.